colleagues Elliot, Tyler, and Winston. We're from the Green School in South Florida, and we're excited to present to you all the educational benefits of PocketQubes in a pre-college setting.
So before we actually get into the PocketQubes and their benefits, we would first like to expand a little bit off of what Mr. Simmons was stating earlier and give a little bit of background about the Wolfpack. So the Wolfpack, originally founded in 2015, is a group of students comprising mainly middle and high school students and aging from 10 to 19 that designs, builds, tests, and flies their very own satellites. As of now, we have 2 operational satellites. We have an additional satellite that will be launching early March of this year, and we have a 4th satellite that was recently selected to fly sometime in 2025. We employ a mission of trying to get students to design, build, and test fly their very own satellites by using 2 main philosophies. First, the blue sky learning philosophy, which is created by Mr. Simmons, and second, the techies and talkies approach, which divides students that choose to work on the more technical side of things such as building the satellite, and those who choose to present papers and write their and advocate. We also work with companies such as Near Space Launch and Near Space Education to improve our networking skills and also get hands-on learning experiences in the world of STEM before students actually graduate high school or college. So in 2015, we began to work on our first satellite, WISat-1, which Dylan and Mr. Simmons previously mentioned. This satellite was based off of the Near Space Launch fastbus structure and was a 1U CubeSat measuring 10 centimeters by 10 centimeters by 10 centimeters. This satellite was incredibly important because it was the first satellite fully proposed by middle school students, and it was also the first satellite to be selected by NASA's CubeSat launch initiative. The mission of this satellite was to test the viability of extremophile bacteria in space and to see if they would survive and thrive in orbit. We were selected for the 8th round of NASA's CubeSat launch initiative in 2017, and we eventually launched out of Vandenberg Air Force Base in 2018. Shortly after, we began to work on our second satellite, CubeSat-1, which was testing capacitors' ability to act in place of the current lithium polymer batteries that we use in spacecrafts today. This mission, much like WISat, is a 1U satellite that was based on the Near Space Launch fastbus structure and was selected in NASA's CubeSat launch initiative. We were selected in the 10th round of NASA's CubeSat launch initiative. We eventually launched out of Kennedy Space Center in 2022. Now onto a more current satellite, FlipSat-1, sorry. This satellite will be launching early March, and it is half the size of WISat and CubeSat, measuring a 0.5U satellite. Because of its size, the satellite will be a hosted payload and will also be a free flyer on Troop hardware, which is hardware designed by the same company that creates our fastbus structures. It was proposed with 2 main missions. First, to establish microbits processing hardware heritage, and second, to measure the effectiveness of hardening technology in orbit. Much like WISat and CubeSat, this satellite was fully soon proposed and built. In the near future, we will be launching WolfSat-1, which is a satellite that tests Ideonellus canesis bacterium and its effects and ability to digest PET plastic, which is a single common use plastic that we use every day in microgravity or environments. Ideonellus canesis is a bacterium that was found in a Japanese landfill that has the ability to digest plastics. And if the satellite when this satellite is launched, it will be testing to see if this will be a good alternative to the current recycling means that we have in space. This will be incredibly important because it will create better recycling use in manned space missions such as trips to the ISS. And we'll be doing this by measuring light-emitting diodes that will show if the PET plastic is being digested, and if it is digested, and if it is, how quickly.
Now I'd like to introduce the Green Aerospace Team, or GAT. The GAT is composed of a group of dynamic middle and high school students ranging from the ages of 11 through 18. As they are still in their nascent stages, they are mentored by the Wolfpack, who are experienced in the aerospace field. This collaboration was created on a joint vision to teach students essential skills and inspire the younger generation to pursue STEM education in a very fun way. What's quite exciting is our inaugural project, which we hope to launch by 2025. It is the GreenSat-1. The GreenSat-1 is made possible by a partnership with Near Space Launch, or NSL. NSL is a US-based company that specializes in integrating payloads into their fastbus structures. GreenSat-1 is based on the 1U The GreenSat-1 is based off of the 1U fastbus structure that has flight heritage and a technical readiness level of 9. We also know this fastbus structure is reliable, as the CubeSat-1 and the WifeSat-1 use the 1U fastbus structure. The objective of the GreenSat-1 is to implement machine learning algorithms to validate the operation of a microfluidic device that mimics bone fluid forces. From this mission, we will better understand the effects of microgravity on the skeletal structure so that in the future, we could have longer distance space missions. Now let's discuss the importance of smallsats in the US. These innovative satellites have been very impactful to space exploration as they facilitate many advanced research, such as Earth observation, telecommunication, and many space sciences. These satellites also facilitate rapid experimentation, which is crucial in this aerospace field as technological advancements occur rapidly. Due to their accessibility, they have been very impactful to education as they reach a larger community of organizations that are able to offer students hands-on learning opportunities. Now let's review the PocketQube. Robert J. Twiggs, after pioneering work with developing the CubeSat, introduced the PocketQube standard and created a new era in the picosatellite class that aimed to democratize access to space and create a boost in space exploration. This has already been impactful. The impact of this has already been shown with the adoption of PocketQubes throughout the aerospace industry. And a great example of this innovation is Alba Orbital. Alba Orbital is a company based in Scotland that was founded by Tom Walkinshaw, and they specialize in payload integration into their PocketQube platforms, such as the Unicorn platforms. Their mission is to democratize access to space by rendering satellite launch and manufacturing opportunities more affordable. As a leading PocketQube manufacturing company, they have 41 successful launches, one of their more notable ones being the Unicorn satellites. As I stated earlier, the Unicorn satellites are now platforms, but in the earlier stages of Alba Orbital, they launched the Unicorn 1 and the Unicorn 2. The Unicorn 1 was a 2P PocketQube that was launched into low Earth orbit to test a radio technology, and the Unicorn 2 was a 3P PocketQube, also launched into low Earth orbit for Earth imaging. Now, let's consider the comparisons between the CubeSat and the PocketQube. To begin, the CubeSat is a 10 by 10 by 10 centimeter form factor with 1 unit of a CubeSat being denoted as 1U. The mass of 1U can be up to 1.33 kilograms. On the other hand, the PocketQube is a 5 by 5 by 5 centimeter form factor with 1 unit of a PocketQube being denoted as 1P. The mass of 1P can be up to 250 grams. So what's quite interesting is that not only is the PocketQube a smaller and more cost-effective solution, it is also more compact or dense, as the mass to volume ratio of a PocketQube is much greater when compared to a CubeSat.
Now let's transition into the technical side of PocketQubes, the 5 by 5 by 5 centimeter form factors. PocketQubes, compared to larger satellites, are much more budget-friendly for educational institutions and in the pre-college setting to enhance hands-on STEM learning. Because of this low price, they are affordable for government entities as well as private entities to expand the aerospace sector of our economy. Also, because they are relatively new, there is a large possibility that they will be selected for grants as well as funding programs. In terms of price, PocketQubes are much less expensive than other satellites such as the 1U and 2U CubeSats. 1U and 2U CubeSats can range from $50,000 to $1 million US, while the PocketQube's manufacturing and launch costs are each lower than $50,000. Although this can change depending on device, each PocketQube is still much lower than other larger satellites. PocketQubes have many advantages, including that they're much more budget friendly, but they also allow students to learn the communication system applications as well as understanding technological theory and practical application. Although they are a smaller payload, they're still beneficial for educational institutions and in the pre-college setting. So the PocketQubes encompass educational philosophies such as experiential learning as well as hands-on learning, and are a vital tool in the STEM pipeline because they allow students to design, build, test, and fly their very own satellites before they enter the workforce. They also help students gain skills such as technological and problem-solving skills and understanding theoretical concepts.
PocketQubes provide a great way for students in middle and high school to get real-world science and engineering skills which they wouldn't have otherwise. It also involves students in the design all the way to the launch process, and whilst PocketQubes build science and engineering skills, they also promote teamwork, problem solving, and project management, which are all essential skills for fields not only in the STEM field. PocketQubes, whilst being able to be used in middle and high school settings, they can also be used in the college setting and even in the highest levels of academic research. PocketQubes also promote better international partnerships with countries that wouldn't otherwise be considered because of their low cost. PocketQubes also involve students in space technology, which is very important for how the space economy is growing so rapidly. Now let's move to some successful PocketQube missions. PeakerSat-1. PeakerSat-1 was created by students from Morehead State University and Sonoma State University, and it was launched by UNISAT-5 in 2015 and is of the 2.5P form factor. It re-entered Earth's atmosphere in 2019, and its objective was to validate and verify all components of the PocketQube in a real space environment. Now onto ROM2. ROM2 is created by a satellite team called ROM Space, which consists of high schoolers and is based in Bucharest, Romania. It's so influential because it's the first PocketQube launched by Romania, and it was launched with the help of Alba Orbital in 2023 on a SpaceX mission in Vandenberg, California. Its nickname was the Space Sparrow because of its small size and its objective, which was to observe the Earth utilizing a 2-megapixel camera.
To review, PocketQubes are a 5x5x5 centimeter form factor with one unit of a PocketQube being denoted as 1P. The mass of 1P is up to 250 grams. Some advantages of PocketQubes are that their cost efficiency and compactness have democratized access to space, allowing for a wide variety of organizations to test new technologies and for more educational organizations to offer students hands-on learning activities. PocketQubes have also been a great positive influence in STEM education as they are able to be implemented into many subjects in the curriculum like physics, math, and computer science. Also, their development time is very short, being under a year, so students are able to manufacture these satellites during their time in school. Experience with these satellites also teach essential skills like coding, hands-on electronics, optimization, and project management. Thank you for listening to our presentation, and any questions?